Hello to everyone. In this video we will talk about what I have done during the additional useful knowledge course of this semester during the second year of my master course in the academic year 2022-2023 at the University of Genoa. So the topic that I have chosen is an introduction on OpenCL and on FPGAs. What is the activity that I have chosen for this additional useful knowledge is an online course on the Coursera website platform about this introduction of this OpenCL and FPGAs. Related to these online courses, there are also some quizzes that I have done and some practical assignment, writing code about OpenCL. Why I have chosen this activity? Because at first it's related probably to my master thesis, since my master thesis will be about analysis of an clustering algorithm and try to improve with parallelization and with API like OpenMP and others this algorithm. And so OpenCL is a kind of way for improving the performance of an algorithm and is related. And is also related, OpenCL, to a course that I have followed these years, that is the high performance computing course. Another reason is the personal interest in this field, in this high performance field. What is OpenCL? OpenCL is based on C++ and is a low-level framework for heterogeneous computing that provides hardware acceleration by using a host API and specific kernel language. What is FPGAs? FPGAs is an integrated circuit, is literally field programmable gate array, because this integrated circuit is designed to be configured by a customer or a designer. For this reason, the name field programmable. FPGAs have a remarkable role in embedded system development due to their capability to start system software development simultaneously. And another application is for parallelization of computable problems and hardware acceleration. And of course, the main pros is the efficiency in about power efficiency and performance improvement. So OpenCL is divided in host side language, that is the main part of the code, the one that runs in the normal way. So I mean in the CPU, on the CPU. And is also divided, and the host is in this case like the manager of what, with a specific memory, and is the manager of the devices that are like employee. In fact, the OpenCL is divided also in the device side language, that is the part of the code that we want to improve, that runs on GPU or FPGA. And so the devices are like employee managed by the host, each one with their own memories. What is the program flow of OpenCL? So at first we want to create the context to associate OpenCL device. Secondly, we create programs and build these programs. As third operation, we want to extract kernel that we want to execute from these programs, and after translate kernel code into object for set up a kernel data and arguments for at the end encoding the kernel in the command queue. Compiled kernel for Intel FPGAs is converting kernel code into FPGA stream. Use the compiler that is the compiler for kernel, that is AOC. Kernels need to be translated into AOC object file in order to generate after the AOC executable files. By default, the host launches device tasks asynchronously, unless synchronization is specified. The host, for example, if launches two kernels, their execution is asynchronous, but also with respect to the host functions. we need synchronization techniques like events or blocking memory. The kernels is divided in two different types: the ND-range kernels and the single work item kernel. The ND-range kernel is like the traditional way of writing kernel code in OpenCL. They provide a way of explicitly implementing data parallelism when we are doing computation. So the goal is to break up data of the problem, and in this way the computation becomes simple and quick. So when the problem of the data of the problem are broken down into many identical concurrent threads, each thread is called work item, and the complete amount of work is called the ND range. ND means n dimension because we can use 2, 3 or more dimension. And but we have the first dimension that is like the global dimension, so the number of total threads, and the second dimension is the number of threads per work group, because we can group work items in groups, and for example, if we have 512 threads, we can have a second dimension. This is the first dimension. We can have second dimension of 64, so 8 groups of workers, each one composed by 64 work items. In order to implement instead a single work item in your host code, you simply launch a kernel with one in each of the dimension. This kind of kernel is very useful when you have a data stream, because you cannot use ND-range kernel, but this kind of kernel is more suitable. So you transform the data parallelism into a pipeline parallelism. It is also suggested to use this kind of kernel when there are data dependency, or when your data are not fully available when you launch the kernels, and also allows to unroll loop execution for a fast throughput. The SDK of OpenCL, so the software development kit, offers you some features like the AOC offline compiler, the host libraries, and the AOCL utility, that is like an executable that can perform many common tasks, and also the Intel Code Builder, that is like a plugin for VS Code or Eclipse for an easy way to develop the code. So what I have learned following this course and studying these arguments, so I've learned what is OpenCL and what is the hardware FPGAs. I've learned how to create an OpenCL programs, so respecting the flow of the program following the instruction of OpenCL. And I have learned also how to use the host and the kernel, how to communicate them together. And I have learned, so at the end, how to increase the performance of our program with this kind of APIs. In conclusion, we can say that we have discussed about what is OpenCL, what is the kind of way that we need to use with OpenCL for programming, for writing our programs, and for exploiting the FPGA hardware architectures. I have showed how OpenCL can improve the performance with the different kind of kernels, one tailored for some cases, and the other one, the single work item kernel, tailored for others. And in the end, we have learned another way, like OpenMP, or there are some other ways for increasing the speed, the performance of your code, but also OpenCL is one of them, and we have learned another way to do that.